In this video, I'm going to walk through two exercises that involve roots and exponents, and the goal of both of these exercises is just to simplify the expression using the order of operations. So the first one says, a nurse needs to calculate the number of milliliters to administer based on a patient's body surface area. And as it is noted, this is something you will be doing later in the MAT 150 course. We're told the patient weighs 202 pounds and is 61 inches tall. This expression right here, once simplified, is going to give us the number of milliliters to administer. So what we need to do is just simplify this expression. Now, this is different than some of the examples we've already seen because we have a square root right in the middle of this expression. But when you have a square root in here, it's nice because square root, the symbol, can be treated as its own grouping, if you will. It's very similar to brackets or parentheses in the sense that if we have another expression, a smaller expression, underneath the square root, then this is something we need to simplify first. We want to simplify what's inside the square root, very much like we would simplify what's underneath or within parentheses. So what I'm going to do first is just simplify what's inside the square root. So I'm not going to do anything with this 50. And underneath the square root, I'm going to take 202 and multiply that by 61, and I get 12,322 divided by 3,131, and I'm going to multiply that by 1 divided by 10. And since this grouping right here is also in its own parentheses, I can simplify what's in there. And we know 1 divided by 10, that's 1/10, and decimal form is 0.1. So now I'm going to simplify what's underneath the square root a little bit more. And if you wanted to, you could simplify, you could put this whole thing in your calculator. You could put the square root of 12,322 divided by 3131. And when you put that whole quantity in your calculator, you get, so I'm just going to put this in here, 50 times, this value is 1.98, and that's just approximate value. That's an approximate value. And now we have only multiplication, so we have 50 times 1.98 times 0.1. So I'm going to put that whole thing in my calculator. Multiplication is commutative, and it doesn't matter here since this is the only operation left. We can do all of it in one big string. We get 9.9. We would administer 9.9 milliliters. Now, later on in the course, when we are calculating the body surface area, what we're going to have to do is we'll have to be able to plug this whole thing in our calculator. So we could have actually plugged the square root of this product and then the division, that whole thing in the calculator, but I wanted to do a little bit of simplification. And what we find is when we put this in our calculator, we're not going to get a very nice number. And 1.98 is just an approximate value, and that is something we're going to be rounding to the hundredths place later on in the course. The point here, again, is just to illustrate that the square root is being treated here, what's underneath there, it's being treated as its own grouping. So we can use our rules with parentheses, multiplication, division, and so forth inside that square root symbol. The next exercise is calculating a male's lean body mass. And this is just the amount of weight that's on an individual's body that's not fat. And we are given this really long formula here involving multiplication, division. I see some subtraction, I see some exponents. And I have some variables, W and H, and we're told that we need to plug in the patient's weight in kilograms for W and their height in meters. We're going to replace that with H. So this is something that's a little bit new that we haven't seen yet. We're going to evaluate this expression for these quantities. So I'm told that the patient's height is 1.7 meters. So that height, I can plug in 1.7 in its place, and the weight of the patient in kilograms is 70. So all I'm going to do first is just anywhere I see a W, I'll replace that with a 70, and anywhere I see an H, I'll replace that with 1.7. That's going to be my first goal. I'm just going to do that now. So there's a lot going on in this example, and we have a lot of parentheses. We have a grouping here on the left-hand side, which involves some multiplication, and then we have groupings, parentheses within larger parentheses, and then some exponents as well. So when you have an example like this, we really want to start on the very inside. What's the most inside component of this grouping? That is this multiplication right here. So that's what I'm going to do. I'm going to multiply this quantity, and that's the only thing I'm going to multiply. So I went ahead and did that, and I took 100 times 1.7 and got 170. And now we have to be really careful here because I am dividing by its squared quantity. So I need to square 170, and I need to do that now. So I'm going to square 170, and I'm also going to multiply this over here, 1.1 times 70. Because this is its own grouping over here on the left, that's not being manipulated in any way, so I'm going to multiply this as well. So I went ahead and did what's underlined in red, so I multiplied this quantity to get 77, and I squared this quantity here. And this is really important. I want to square this quantity before I do the division. I could see some individuals making mistakes here. They might want to divide first before, or divide and then square. But that's not quite correct here. We're squaring 170. We do the exponents before the multiplication and division. So now I am left with this quantity. I have subtraction, multiplication, I have an exponent and division. We know with the parentheses, or excuse me, with PEMDAS, so parentheses exponents, multiplication, division, I want to multiply, or 70 times 70, I want to undo this 70 squared, and I'm going to do that right now. So I squared 70 and got 4,900, and I am left with this expression here, 77 minus 128 times this division problem here, 4,900 divided by 28,900. This is similar to what we saw in a previous video where students who multiply, strictly multiply the order of operations might multiply these quantities first, but we actually need to divide these quantities, and we need to multiply by the quotient of this quantity here. And if you recall in a previous video, I suggested that it might be helpful, so I'm just going to go over here, it might be helpful to rewrite this as 128 times this division property. It could be helpful to use fraction notation to be a little bit clearer here as to really what we're doing. We're taking 128 and we're multiplying times this quantity here. Using fraction notation, it might make a little bit more sense. It might be a little bit more helpful in this way to see I'm taking 128 times this value here. So this is what I'm going to plug in my calculator. You could, if you want to take 4,900 divided by 28,900 and then multiply by 128, you should get the same answer. But I'm going to do this whole quantity in my calculator right now. So I did that multiplication and division, and I am left finally with 77 minus 21.7. And this 21.7, I just rounded that to the tenths place. This was not the exact value I got. It's an approximate value. So the last thing to do is to take 77 and subtract 21.7, and I get 55.3. And again, the solution here, the value that we arrive at, 55.3, is an approximate value because we have this quantity here, 21.7. It's going to be rounded, so this is only an approximate value. To finish up this problem, let's think back to what this 55.3 represents in this problem. We just found this individual's lean body mass, which is the amount of weight on the individual's body that is not fat. So we are given 55.3. This is the amount of weight, and we would want to go back to double check, is this the weight in kilograms? Is this weight in pounds? we would want to research a little bit more about this formula to confirm what is the unit on our 55.3.